Hi-ho, Mr. Gucci here with the last help video for Unit 10, in which we are going to go over questions 9, 10, and 11 from the final exam review, Chapter 10. So, first step, we are going to have to balance this equation. And oh, what a doozy this one looks like. All right, I've copy and pasted it over here. Let's take a look. All right, I don't even know where to start on this. So let's just count up all the elements that are present. Okay, so on this side, we have 6 carbons, and on this side we have 6 carbons. Okay, so far so good. Okay, on the reactant side we have 6 hydrogens, and on the product side we have 5 and 1. That's 6 hydrogens. Okay, good so far. All right, then we have 2 chlorines on the reactant side, and a chlorine here and a chlorine here. That's 2 Oh my gosh, guys, it's ones across the board. All right. Wow, Mr. Gucci. Wow. Just just wow. All right, fantastic. Well, for an unrelated question, okay, we have to do number 9. Let's see here. Okay, 2 students were able to make 36.8 grams of chlorobenzene in the lab. What was their percent yield if their theoretical yield was 39 grams? So here we go. Percent yield is equal to what you got in the lab, like literally weighed out in your hands, all right, if it's not toxic, divided by the predicted, all right, the theoretical amount. So it's what you got divided by what you predicted you should have gotten. So in this case, they were able to they actually got 36.8 grams out of a theoretical predicted amount, 39.0 grams. So what is 36.8 divided by 39? You get 0.944 or 94.4% yield. There we go. That's the answer to number 9. Okay, we didn't even need to use the balanced equation, but we are in this next one. All right, here we go. Question number 10. Okay, question number 10 is if 50.0 grams of benzene. Oh, this is not even a complete sentence. Oh, yeah. If you, oh God, okay. All right, there we go. 50.0 grams of benzene will require what mass of chlorine gas to fully react? Okay, now which one is the benzene? Benzene is C6H6. All right, how do we know that? Well, Cl2 is chlorine. HCl is hydrogen chloride or hydrochloric acid. And above, we learned that this is chlorobenzene. So benzene is C6H6. So let's get to it, okay? Here we go. We have got 50.0 grams of benzene. We want to figure out how many grams of chlorine gas is going to be required. So first step is we got to get these grams here of benzene into moles of benzene. All right, so out of grams into moles. Now, to go from grams into moles, we need the molar mass. That's 6 carbons, so 6 times 12.01. That's the molar mass of carbon, lest we forget. There's a periodic table somewhere here. Yeah, there we go. Yeah, carbon right here, 12.01 times 6 plus 6 hydrogens, 6 times 1.008. And we get 78.11. So 50 divided by 78.11, and we get 0.640 moles of benzene. Okay, so let's plug it into the next step. 0.640 moles of benzene And we want to figure out how many moles of chlorine. So we have to get out of benzene, C6H6, into chlorine. And this is easy because it's ones across the board. So we're going to end up with the same number of moles of chlorine. Sometimes that happens. In this particular reaction, every mole of benzene consumed also consumes 1 mole of chlorine gas. All right, cool, cool, cool. So we'll plug this in. Boom. Now, if you have 0.640 moles of Cl2, what mass is that of Cl2? So I want to get out of moles and into grams. I'm going to go to my periodic table. Cl is 35.45, but I got Cl2. So 35.45 times 2 equals, yes, 70.9 grams. So 0.640 times 70.9, and we get 45.4 grams of chlorine must be consumed in order to fully react with 50.0 grams of benzene. Okay, very good. So that's the answer to number 10. All right, last question and last one for Mr. Gucci before he has to go to bed. How many liters of HCl gas will be produced from the combustion of 6.75 liters of benzene? So I'm going to do this one in the long form, all right? For all those people that have been screaming at me, just to do it the long way, Mr. Gucci, make one problem. Fine, fine, fine. I'm convinced. 67.5 liters of benzene. And I want to know how many liters of HCl will be produced. So, first step is we have to get out of liters of this stuff into moles of this stuff, okay? So that is 22.4 liters is 1 mole. Now we have to get out of benzene and into hydrochloric acid. All right, well, again, this is easy. 1 to 1. All right. Now we need to get out of moles of HCl and into liters of HCl. So that relationship is 22.4 liters is 1 mole. So let's see here. 67.5 divided by 22.4 times 1 times 22.4. Well, guess what? Everything actually cancels out, and you're left with 67.5 liters. In this particular reaction, the same amount of benzene gas is being consumed as HCl gas being produced in a 1-to-1 ratio. For every liter consumed, you spit out a liter of that. All right, and that's the end of the video, guys. I hope that helped. Good luck to all of you. Good night.